Good morning, children. So let us proceed with chapter 6. Now we are going to do question number 5 for exercise 6.1b. Okay. So question 5.1, prove that 1 plus tan theta into tan 2 theta is equal to sec 2 theta. Okay. So we'll start with the left hand side. So left hand side is equal to 1 plus tan theta into tan 2 theta. Now this 2 theta can be written as theta plus theta. Clear? Now you know the formula tan A plus B. Okay, so using that you can write tan theta plus tan theta upon 1 minus tan theta into tan theta. Clear? So you get 2 times tan theta upon 1 minus tan square theta. Clear? Here this will multiply inside, so you get 2 times tan square theta upon 1 minus tan square theta. Now take the LCM. Okay, so you get 1 minus tan square theta plus 2 times tan square theta. So you get 1 plus tan square theta upon 1 minus tan square theta. You know that this is nothing but sec square theta. Clear? So write sec square theta. Yes. And here this tan square theta can be written as sin square theta upon cos square theta. Cross multiply, or you can say find the LCM, and you will get cos square theta minus sin square theta, and in denominator you get cos square theta, and that cos square theta goes in the numerator. Clear? So here when you see sec square theta into cos square theta becomes 1. Okay, so you get 1 upon, and for this cos square theta can be written 1 upon cos theta into cos theta minus sin theta into sin theta. Clear? And this can be written as 1 upon cos theta plus theta. Clear? So you get 1 upon cos 2 theta, that implies sec 2 theta, that is your right hand side proved. Next, question number 7. If cos A plus B into sin C plus D is equal to cos A minus B into sin C minus D, so this. Okay, so what we'll do is, given this, okay, so we write this. Now A plus B and here A minus B, so this A minus B will bring down, okay, and this C plus D will take to the here right hand side. So we get cos A plus B upon cos A minus B is equal to sin C minus D upon sin C plus D. Now after this we will use componendo and dividendo for here. Okay, you know that componendo and dividendo we had done in class 10. Okay, like here if you have A upon B equal to C upon D, then by componendo and dividendo you will get A plus B upon A minus B equal to C plus D upon C minus D. So using componendo and dividendo, this can be written as cos A plus B, okay, plus this denominator cos A minus B, and down we'll get cos A plus B minus cos A minus B, and for this we'll get sin C minus D plus sin C plus D, sin C minus D minus sin C plus D. Okay, now cos A plus B plus cos A minus B is equal to 2 times cos A into cos B. Okay, in fact when you expand this and this, okay, and you will see that 2 terms get cancel over here, okay, and then you get this, okay, 2 cos A into cos B, and for this you'll get 2 times sin A into sin B. For here you'll get 2 times sin C into cos D, and for this you'll get 2 times cos C into sin D. Clear? And here 2 cancel, here 2 cancel. Clear? Cos A upon sin A becomes cot A, cos B upon sin B becomes cot B, sin C upon cos C becomes tan C, and this cos D upon sin D becomes cot D. Clear? This tan C, it comes to the left hand side, okay, and it becomes 1 upon tan C. 1 upon tan C is nothing but cot C. So cot A into cot B into cot C is equal to cot D. Proved. Okay, and for this, okay, I wrote straight this. Yes, if you want to expand and then you will get this, okay, otherwise what you can do is you can remember this. Okay, you can remember this. Next is question number 9. If tan beta is equal to n times sine alpha into cos alpha upon 1 minus n sine square alpha, prove that tan alpha minus beta is in bracket 1 minus n into tan alpha. So we'll start with left hand side. So left hand side, tan alpha minus beta is equal to tan alpha minus tan beta upon 1 plus tan alpha into tan beta. You know the value for tan beta, substitute, okay, then you do the simplification, okay, and you will get this, clear, and simplify it further, okay, and you will get your right hand side, okay. So when you go through the steps, okay, one by one, you can easily get it, okay. So please go through it. Question number 10. 1. If sin alpha into sin beta minus cos alpha into cos beta plus 1 is 0, show that 1 plus cot alpha into tan beta is equal to 0. Clear? So here given sin alpha into sin beta minus cos alpha into cos beta plus 1 equal to 0. So here what we can do is we can write this part as this minus in bracket cos alpha into cos beta minus sin alpha into sin beta, and this plus 1 will be taken to right, it becomes minus 1, okay. So here minus and here minus cancel, so we get cos alpha into cos beta minus sin alpha into sin beta equal to 1. This is expansion of this cos alpha plus beta, so for this we can write cos alpha plus beta equal to 1, and you know that cos alpha plus beta is equal to 1 implies when you're getting 1, that means cos 0, okay. So cos alpha plus beta is equal to cos 0 implies alpha plus beta is equal to 0, that means alpha equal to minus beta, clear. So we know that alpha is equal to minus beta, so we'll use this value, okay, for this one, clear, on left hand side for this, okay, and that way we can show right hand side equal to 0. So left hand side equal to 1 plus cot alpha into tan beta, okay. So in place of alpha I can put minus beta, so here minus sign comes out, so you get 1 minus cot beta into tan beta, and cot beta into tan beta will be 1, so 1 minus 1 is equal to 0. It is your right hand side proved. Next is question number 10.2. A cos x plus beta is equal to b cos x minus beta. Prove this, okay. So what we'll do is we will start with this. So a cos x plus beta is equal to b cos x minus beta, so we'll expand this and we'll expand this, okay, and so after expansion we get this, then open the bracket, a is multiplied throughout, here b is multiplied throughout. So here you can see that we have got cos x cos beta, here we have got cos x cos beta, so we'll take this one side, and here we have got sin x sin beta, we'll take them one side, okay. So we get this, clear. Here cos x into cos beta common, okay, in these two, so we get a minus b in bracket and into cos x into cos beta, and here we get a plus b sin x into sin beta, clear. So what we are supposed to prove, we are supposed to prove a plus b tan x, okay, and here a minus b cot beta. So I have here a minus b and I need cot beta over here, that means cos beta upon sin beta. So sin beta take it to the left and cos x take it to the right, so you get a minus b into cos beta upon sin beta equal to a plus b sin x upon cos x, so you get a minus b cot beta equal to a plus b into tan x, clear. So it's proved. Next is question number 11.1. It is homework for you, okay. So if tan alpha equal to 2 times tan beta, show this one, okay. So what you have to do is you have to expand your numerator and denominator, you have to take something common, okay, and you'll get your tan alpha upon tan beta as 2, okay, use it and you can get it. So try by yourself. Question number 11.2. If tan theta equal to a sin x plus b sin y upon a cos x plus b cos y, prove this, clear. So we will start with this given part. So tan theta equal to a sin x plus b sin y upon a cos x plus b cos y, cross multiply. This tan theta can be written as sin theta upon cos theta. This cos theta will be taken to the right hand side, okay. So we get this. Now here you can see that this has a, this has a, okay. So take this on left hand side and take this on right hand side, clear. So you get this a sin theta into cos x minus a sin x into cos theta is equal to b cos theta into sin y minus b sine theta into cos y. Okay, a is common over here, and here you see b is common, so you wrote a in bracket sine theta into cos x minus sine x into cos theta is equal to b, in bracket cos theta into sine y minus sine theta into cos y. Okay, so this part is nothing but expansion of sine theta minus x. Okay, and what we have to prove, actually here we need sine theta minus y. Okay, so right now we have cos theta into sine y, okay, minus sine theta into cos y. So what we can do is we can take minus sign common from this bracket, so we get minus b, and in bracket sine theta into cos y minus cos theta sine y. Now this is expansion of sine theta minus y. Okay, so we wrote, now this part can be taken to the left hand side, so you get a sine theta minus x plus b sine theta minus y equal to 0. Proved. Okay, question number 12, it's homework. If tan beta equal to sine alpha into cos alpha upon 2 plus cos square alpha, show that 3 tan alpha minus beta is equal to 2 times tan alpha. Okay, so here you have to start with your left hand side, this one. Okay, so 3 times tan alpha minus beta. Okay, expand this and you get this. You know the value for tan beta, substitute. Okay, and try by yourself. Okay, simplify and you should get 2 tan alpha. Okay, at the end. Question number 13, if an angle theta is divided into two parts, so there is one angle which is divided into two parts, alpha and beta, that means theta is nothing but sum of alpha and beta, such that tan alpha is to tan beta is equal to x is to y. Okay, so that sine alpha minus beta is this, so we have to show this. Okay, so here given theta is alpha plus beta and tan alpha is to tan beta is equal to x is to y. Clear? So we'll start with this left hand side. Left hand side is sine alpha minus beta, expand it, you get this. Now here what we'll do is we need sine theta. Okay, so we'll multiply and divide by sine theta. Okay, so we get this, but theta is nothing but alpha plus beta, so for this I can write alpha plus beta. Now you can expand the denominator also, so I get sine alpha cos beta plus cos alpha sine beta. Okay, till now I'm not done anything to this numerator. Clear? Now what I'll do is I will divide numerator and denominator by cos alpha into cos beta. Why? Because I want to use this value, tan alpha upon tan beta is equal to x upon y. Okay, I want to use that value, so I want to get that tan alpha upon tan beta. So in order to get tan alpha upon tan beta, if I divide this by cos alpha, okay, and this by cos beta, okay, so that way I can get tan alpha upon tan beta, and we'll do same thing for denominator also. So we are dividing numerator and denominator by cos alpha into cos beta, so you get this. Clear? So each term divided by this, so you get tan alpha minus tan beta into sine theta, okay, upon tan alpha plus tan beta. Now take tan beta is common, okay, from numerator and denominator, so you get tan beta, and here you get tan alpha upon tan beta minus 1 into sine theta. Here you get tan beta, tan alpha upon tan beta plus 1. Okay, so tan beta cancel, and tan alpha upon tan beta is nothing but x upon y, because it's given over here that tan alpha is to tan beta is x is to y. Clear? So here tan alpha upon tan beta I can write x upon y. Clear? So substitute, simplify, and you get your right hand side. It's proved. So this is all for today. Okay.